Thank you, Mr. Chairman, and it's a great pleasure to be here at this conference to have a chance to talk to you about natural gas. And I'd like to take a lead from what Mr. Tripathi just indicated about gas and a special role it may play in India in transportation. And what I'm going to do in my comments here briefly is to focus on the transportation piece and look at some of the interesting options that might play out for natural gas there. One of those is LNG, but there are other possibilities for gas. So I'm going to start with a brief introduction talking about drivers for thinking about natural gas, because I think we've had a pretty good coverage of that already. But basically the driver here is that there's cheap and abundant natural gas out there. There's also a rapidly growing transportation market, particularly in countries like India and China, and that's going to drive need for more transportation fuels, natural gas being a particularly convenient fuel that we might use. An interesting sub-theme in transportation is projections out to 2040, which suggests that, in fact, we're going to have a glut of diesel relative to gasoline on the global market. And there's a question about what you might do by way of heavy-duty trucking using lighter fractions, gasoline or something else. And I'll talk about how gas might fit into that something else category. Then talk about some of the pathways for gas to address these opportunities. CNG being one that's already being used in India. I'm not going to say much more about it than that. LNG is a second option, and then third is a variety of ways to take natural gas and convert it into liquid fuels that can substitute directly into the transportation market. So as a brief summary of the resources available for natural gas globally, this is a slide that comes out of the Future Natural Gas Study from MIT back in 2011, which summarizes natural gas resources from conventional and unconventional sources. The shale resources in these different accountings are only listed for North America, for the U.S. And Canada, which is, of course, not to say that shale is not available elsewhere. In fact, we believe, and there's evidence clearly, that shale is pretty ubiquitous around the world. It's just that it's not as well characterized globally as in North America, so we don't list the reserves there. Major point here is simply that there's a lot of gas and it's spread pretty broadly globally. Second point is that the gas is cheap. Right? So this is a look at the cost supply curves. This is what in our future natural gas study, this is what goes into the global economic modeling scenarios. And so these curves show how much gas is available at what price, which is, of course, the right question to ask about gas availability. And we have two different limits here, limits for 95% probability that there's that much gas and 10% probability. The higher probability, of course, is more conservative and further to the left, has a lower gas volume estimate. We'll use the mean estimate for discussions here. You see that in this estimate there's some 8 to 10,000 TCF of gas globally available at under $4. So lots of very cheap gas. Also, as Mr. Tripathi alluded, there is a substantial cost to shipping gas if you're not going to put it in a pipeline. If you want to ship it by tanker, you have to liquefy it, which is expensive. There's the shipping, which is not as expensive, and then the regasification process to put it back into the pipeline system. The total of that is probably $6 to $8 a million BTUs. So there's a substantial penalty for shipping gas as LNG relative to the base price of the gas, say down here at 4. So in the U.S., as Mr. Tripathi said, prices in the range $3 to $4 a million BTUs today. That would more than double the price of the gas if you ship it. Nonetheless, that can play a major role in spot markets when there's excess gas to be put on the market. And I think we'll hear more about that in other presentations. An important factor that comes out of this need to liquefy gas if you're going to ship long distances, and that high price of liquefaction, is that to date gas markets have developed regionally. So we basically have three major regional markets. There's the North American market, there's the European market coupled with Africa and parts of Asia, and then there's the Asian market with feed in from the Middle East. Right? It would be nice to see, and one of the things we encourage in our future of natural gas study is the development of international markets, which I think would result in better prices globally. Second driver that I mentioned is the growing demands in transportation. We're all familiar with projections out to mid-century of doubling of energy demand globally, driven by increases in population and increases in standard of living. And as standard of living increases, as just pointed out, energy use per capita goes up. As that energy use increases, there's increased demand for transportation, and there's an increase in vehicle stock. Now, this is a look at the projected increase in vehicle stock out to 2050 in three major blocks of countries. There's the developed countries, shown in dark blue at the bottom, other G20 countries in green, and then in the light blue, the rest of the world. In the next three graphs, we break those three regions, three groups of countries apart and look more systematically at growth in vehicle stock by region. You can see that the developing world has moderate growth in vehicle stock. U.S. is at the top of that towards the end of this period by 2050. The major growth in vehicle stock, though, comes in the other G20 countries, particularly in India and China. You see China in red and India in yellow, having increases in vehicle stocks of 3 to 4, factors of 3 to 4 over this 35-40 year period. So very substantial growth in vehicle stock, and associated questions of how to fuel that increase in vehicle stock. And finally, moderate growth in vehicle stock in the rest of the world, but starting from very small numbers. An interesting feature of the transportation fuel mix going out to 2040, 2050 is the increase in diesel powered vehicles relative to gasoline powered vehicles. These are results from Exxon Mobil's energy outlook, a view out to 2040 that they constructed, looking at the transportation fuel mix, and shown on the left is the Asia-Pacific mix, the North American mix, and the European mix. If you look at the North American picture, you'll see the decrease in gasoline use going out to 2040. Gasoline use being the big piece in green. The diesel use increases somewhat to compensate. You could see it over here on the far right. In Europe, gasoline use decreases and diesel use increases. Diesel use is already substantially greater than gasoline use, of course, in Europe. Again, the big effect comes where the large growth in vehicle fleet occurs, and that's in Asia Pacific markets. And you see the very large growth here in diesel in the orangish set of curves. Right. So the question is going to be how do you accommodate that switch in ratio of diesel to gasoline given the physical constraints of refining a barrel of oil. Okay? And we'll come back to that. There are also some other drivers for looking for alternatives to diesel fuel. One of those is NOx, or the NOx and particulate emissions that occur in high pollution diesel trucks. So in particular, trucks that don't use expensive exhaust treatments or low sulfur fuel. It's a major problem here in India and in China, and it's a growing issue in a number of other countries. There's also the potential tightness in diesel availability and increased price. That's associated with projected change in ratio of fuel demands and coupling that with the physical realities of refinery limitations. Thirdly, there's the desire to have an option for oil, so you can have options in case oil prices go up. You can of course use oil when prices are down. And then fourthly, there are greenhouse gas emission reasons to look for alternatives for diesel. So I mentioned at the outset three major pathways for using natural gas in transportation. CNG is used in light duty and heavy duty vehicles. A lot of CNG vehicles on the road today in India. So that's something that's already quite familiar here. Second option is LNG, which tends to make sense only for heavy-duty vehicles simply because of the high capital cost and the need to be able to amortize that over a reasonable number of years, which requires a large number of miles for vehicle use during a given year. And then the third option that I'm going to stress in the remainder of the talk is that of natural gas-derived liquid fuel, so liquids at room temperature that could be used for light and heavy-duty vehicles. So one option here is using LNG as opposed to diesel in trucking. A number of advantages to the LNG. One of those is much lower pollution, less particulates, less NOx emissions. Second is lower fuel cost on an energy basis, but that's an advantage that's eroded considerably with the recent oil price drops going back to last summer. Number of disadvantages for LNG as a replacement for diesel. One of those is the large incremental vehicle cost, and most of that's due to the cost of storing the LNG. A second is lack of operational flexibility, and that's associated with the low temperature, minus 162 C, for the fuel temperature. A third disadvantage is the expense and complexity of the fueling infrastructure. So presumably you would use LNG in fleet shipping where you would do hub-to-hub shipping arrangements, something like a Walmart might do. And then lastly, there's about a 10% lower fuel efficiency for LNG relative to diesel on an energy basis, at least for a high fraction of present LNG engines. So what about this route of going natural gas to liquid fuels, room temperature liquid fuels? The standard route there is to begin with the natural gas, so methane, do so-called methane reforming Steam reforming is the common. You heat methane in the presence of high pressure steam to make synthesis gas, CO and water. That's then reacted over a catalyst. Depending on the catalyst and the conditions, you can get a number of downstream products. The two direct ones most commonly are diesel itself, which I'm not going to discuss here, and methanol. And from methanol you can go to other liquid fuels, but those necessarily would be more costly because it requires additional processing. So methanol is an interesting target liquid fuel here because it's, first of all, a well-established commercial production technology, and it's a standard feedstock for the chemical industry. You can go to lots of different chemicals besides the few transportation fuels I showed on that previous slide. It's the most efficiently produced natural gas, and I might mention for this conference, and coal derived liquid fuel. Right, so it's a liquid fuel you could get either from the gas or from coal. You can produce it from natural gas at a cost that is currently lower than oil-derived gasoline and diesel. The price advantage is not what it was 7 months ago, but it's nonetheless an advantage. You can use it in spark ignition engines by itself, or you can use it alongside the gasoline and ethanol. That happens in China with their M15 mix. And it can potentially provide a substantial... So methanol is an interesting target liquid fuel here because it's, first of all, a well-established commercial production technology, and it's a standard feedstock for the chemical industry. You can go to lots of different chemicals besides the few transportation fuels I showed on that previous slide. It's the most efficiently produced natural gas, and I might mention for this conference, and coal derived liquid fuel. Right, so it's a liquid fuel you could get either from the gas or from coal. You can produce it from natural gas at a cost that is currently lower than oil-derived gasoline and diesel. The price advantage is not what it was 7 months ago, but it's nonetheless an advantage. You can use it in spark ignition engines by itself, or you can use it alongside the gasoline and ethanol. That happens in China with their M15 mix. And it can potentially provide a substantial fuel efficiency improvement, maybe 30–40% relative to CNG engines, depending on how you configure the engine. Some interesting work currently going on at MIT looking at methanol truck engines. This is work by two physicists, Leslie Bromberg and Dan Cohn, using a spark ignition engine technology with the same efficiency, torque, and cost as a high pollution diesel engine, but with a greater than 90% reduction in particulates and NOx relative to these high pollution trucks, for example, here in India, China, and other countries. It would also have an option for gasoline operation. So in that sense, you could look at this approach as a drop-in substitute for gasoline in the distillate fractions of oil refining. There's also an option they're looking at that involves exhaust heat recovery technology on the back end of the engine, which would result in 20 to 25% higher fuel efficiency for a pretty modest additional cost, maybe 5 to 10K extra. Lots of advantages for these methanol engines relative to diesel engines. I'll just touch on one or two of these. First, in efficiency and torque, for the existing spark ignition technology, it's the same as diesel, but with this advanced exhaust heat recovery, you could do 20 to 25% higher efficiency. The retail fuel cost in dollars per diesel gallon equivalent is the same as diesel at $4 a diesel gallon equivalent for both technologies. The efficiency corrected fuel cost, though, for the engine with the exhaust heat recovery would be 70 to 80 cents per diesel gallon equivalent lower than diesel. Both of these have power that's 30% more than diesel. So a number of advantages for the methanol engine. Methanol relative to LNG for trucking, in countries like India and China, LNG and methanol could offer substantial air pollution reduction advantages of a similar magnitude. Methanol would have advantages of lower additional vehicle cost. As I mentioned, the LNG modification on an engine is pretty expensive, maybe $50,000 to $70,000. Methanol would have much lower fueling station costs, $75K versus something in excess of $1 million. Now, LNG would have the advantage of basically lower fuel cost. But that advantage could be relatively small and could be eliminated by high LNG cost in some regions. Greenhouse gas emissions advantages from methanol engines. CO2 emissions from natural gas derived methanol would be similar to those for oil derived gasoline for similar engine efficiencies. With higher efficiency from methanol engines, then CO2 emissions in light duty vehicles would be around 25% less than in the corresponding gasoline engines. CO2 emissions in long-haul trucks could be reduced 15 to 20% relative to diesel. Methane leakage could be minimized by producing the methanol right at natural gas wells. This is an advantage that I haven't mentioned anywhere else, but there are technologies for small-scale gas to liquids, going natural gas directly to a liquid like methanol. If you do that at the well source and then ship as a liquid, you get cheaper shipping, and you also minimize risks of methane leaks from the pipe system. So in summary, these super high efficient engines that use natural gas derived methanol could give us about a 30% efficiency gain over CNG engines, along with some advantages in additional lower cost vehicles, lower fueling infrastructure costs, and longer range than CNG. These might enable much larger use of natural gas-based fuels in light-duty vehicles. They could also significantly expand the use of natural gas-based fuel in heavy-duty vehicles, as we discussed in the diesel truck swap-out. And then lastly, greenhouse emissions could be reduced somewhat relative to oil-derived diesel. So with that, I'll thank you. I thought I would show you what I'm missing today in Boston. This is a picture of MIT, so my home institution, and shows what the Boston Globe yesterday referred to as the Alps of MIT. This is where the buildings crew at MIT is dumping all of the snow they clean up from the sidewalks and the streets on campus, and the students go mountain climbing there to have fun. So this is what you're missing by being here.
Thank you.